Hey everybody, so we're going to be talking about factoring special products. We're going to talk about the difference of squares first, and then we're going to be talking about the perfect square trinomials. So we did talk about this when we were doing FOIL and multiplying all the polynomials. So I want to give you a refresher. So I'm just going to FOIL this one out. We're going to go first, outer, inner, and last. All right, you'll notice your OI terms right here, these actually cancel out. They zero out. So we are left with a squared minus b squared when we are done. So pretty much it's that first term squared and that last term squared if your binomials match, if the insides match, for everything except for the sign, then you can use this. So, for example, with example 1 right here, we have that the insides match and they have opposite signs. Awesome. So we're going to do it with FOIL first. Okay, so you've got first, outer, inner, and then last. Your OI terms zeroed out, so you get 4x squared minus 9. Now think about it. Your first term right here was 2x. 2x squared minus, since they have opposite signs, and the 3 squared. You get 4x squared minus 9. It doesn't matter which way you do it, all right? If this is like, I'm going to mess up, I'm going to keep making the same mistakes, then don't do this, all right? It does make your life easier for factoring, especially when you have something like this. All right, so if I see this, I see a squared because it's a perfect square, and a perfect square being subtracted. So difference of squares, that's what that means. So I take the square root of each of these. 16x squared would be 4x. That would be the square root of it. And minus 1, the square root of 1 is just 1, and then opposite signs, and this would be your answer. If you're like, I don't know how to do that part. Well, why don't we do my fat dog really moves, just in case. So if you've got 16x squared minus 1, we're going to do my fat dog really moves. So you move it on over, and you get x squared minus 16. Factor it. So you get negative 16 and a 0 down here because your b value is 0. Then you get 4 and negative 4. Okay, so I get x minus 4 and x plus 4. Divide by the number. So we multiplied by 16, so now we're going to divide. Reduce, so you get x minus 1/4 and x plus 1/4. And then move. Move your denominator back over if there is one, and you get 4x minus 1 and 4x plus 1, which is the exact same thing we got here. So again, this only works on special products. Right. So we can also do this one pretty easily. Now your first step, always check for a GCF. The GCF that I see between the 12 and the 27 is a 3. And the reason why I always know to check for the GCF is I see that it's set up for a difference of squares, but these two numbers are not perfect. So when I pull out that 3, that GCF of 3, I get 9g squared minus 4. And now each of these are perfect squares. So I can set mine up as 3g, because that's the square root of 9g squared, and then the square root of 4. And don't forget to bring your GCF on down, and that is your final answer. This last one, you'll notice we can't actually do it. And you're like, but Miss Samji, why not? I could just say 3x minus 4 and 3x plus 4. You're right, you could, if this was a subtraction. So this one is actually a prime polynomial because not only is it not a difference of squares, it's not factorable in integers. And you know what? You can't even pull out a GCF from here. So now let's talk about the other ones because that kind of looks like something else we're going to work with. So let's go ahead and do our perfect square trinomials. And this is going to be written as either a plus b squared or a minus b squared. So if you're like, I don't know, let's FOIL it out. So you got a plus b times a plus b. And now we're going to do first, outer, inner, and last. These two are common terms, so I can add them up. And I get 2ab. The rest did not simplify. My OI terms did combine like it normally does. So that's good. And guess what? That's it. Now, the only thing that would change if this sign had been a negative would be a squared minus 2ab plus b squared. So it's your first term squared, your last term squared. And then your middle term is your first term times your last term times 2. First, last, 2. So let's try it out with this one. I'm just going to FOIL at first. Okay, so I get x squared first, outer, inner, and last. So I get x squared minus 10x plus 25. And check this out. I could have gotten that exact same thing. So I have x, my first term squared, my last term, negative 5 squared. Okay, that's 5 squared is 25. And because it's a minus, that first sign is the one that changes and it becomes that minus. And it's going to be negative 5 times x, my first term times my last term, and double it. So negative 10x, which is exactly what we got when we FOILed it out. So again, this is a shortcut if you have perfect squares. You can also use that to factor. So there is not a GCF I can pull out from each of these, but what I do see is right here. Both of these are perfect squares, my first term and my last term. So I know that it's going to be 2y plus 3 squared, but you have to double check it. So this one would be 2 times 2y times 3. Well, 2 times 2 times 3, that's 4 times 3, that's 12y. And that's exactly what we had. So yes, in fact, this is our answer. All right, we've got 7 and 8 here. Okay, you are going to be responsible for submitting number 8 to me. For example 7, you are just FOILing it out, and you are responsible for turning this one into me too. Thanks for watching.